Great. Perfect. Alright, hi everyone. I'm Dev. I work at Dropbox and we are hiring. This is completely necessary for them to sponsor my flight, so I need to say those two things. But this one was done when I was a student in Berkeley. So, and I'm going to talk about password managers. How many people use password managers? Yeah, it's like a completely unbiased sample here. But yeah, so passwords suck, right? Like there's nothing, Alex talked about it, we all work in security, passwords are just horrible. There's no, it's all completely broken. This is like a classic Reddit meme on what happens when you try to set a password. It's just worse and worse, so users hate it. So people who try to be secure are always clicking forget password because, who can remember these things? But most people don't even try to be secure. They just use like 3 passwords everywhere, and that's why we have all these password breaches and all these problems. And so, this just like in the news every year, like 2014, like year of the breach, right? But I love password managers. Password managers are this beautiful solution, right? Like with password managers, you can solve all these problems beautifully. Password managers are like, you don't have to remember so many passwords, you just remember one key password, they take away the autofill, so you don't need to worry about phishing because they won't autofill in the wrong site. They make sure your passwords are super complex, so they're not vulnerable to, brute forcing through hashing and all these things. And it's great. It's like the possibilities of password managers are great. And so it's no wonder everyone recommends password managers. I recommend password managers to anyone I talk to. And the US CERT, when they talk about how do you take care of authentication online, what sort of stuff do you do? They're very clear, right? Like one of the best things you can do is to use a password manager to keep track of each and every password and a unique password for each and every site that you're using. And so it's almost like this beautiful, like one single ring that just solves, that one master password, your password manager, is the key to unlocking your whole digital kingdom. And like the ring, it would really suck if it got to like the wrong people, right? Like you want to make sure that the ring stays with the right people, and if Sauron gets it, like you're screwed. And so securing this password manager is important, right? And so this is totally like a completely push through analogy, but I really wanted to keep this image in my slide. But really what's driving this work is, are password managers secure, right? Like are they actually worth putting all this trust into? And when we talk about being secure, what does this mean for password managers? What is security for password managers? The way I see it, there are 3 key properties when we look at password managers that we want to ensure. The first one is master account security. You want it shouldn't be possible for some random person to just log in to the password manager as you and steal all your passwords. This is kind of obvious. It should also not be possible to someone download and steal your passwords through some other mechanisms like CSRF for authorization issues or something. And for privacy, as we encourage everyone to adopt password managers, we don't want it to be this unique tracker that can be allowed, that will let websites track you across websites, because password manager is one code that will run everywhere. And so if it becomes this another tracker websites could use, that would also suck. So today I'll be talking very quickly about some work I did on looking at real-world, practical, web-based and browser-based password managers and looking at how secure they are. We looked at 5, LastPass, RoboForm, My1Login, Password Box, and Need My Password. How many people in this room actually use one of these? Alright, so maybe you'll be a little sad, but these are all fixed, so don't worry about it. So we found 4 general class of vulnerabilities: bookmarklet vulnerabilities, classic web like XSS, CSRF stuff, authorization issues, and user interface issues. I'll go into detail for each of these, but at a high level, I just wanted to give a TLDR that basically, bookmarklet vulnerabilities, out of the 5 we studied, 3 used bookmarklets had this feature, and all 3 of them were vulnerable with critical flaws. And similarly for all the other cases, so 3 supported authorization and sharing, and out of those 2 were vulnerable. So in the end, no product was safe against all 4. There was something broken in all the 5 products that we saw, which is kind of scary because how important and sensitive password managers are. When I started this work, I was really hoping that there would be a much higher level of security, but unfortunately, that didn't happen. And so today I'll be giving example attacks from each class of vulnerabilities, but I won't be going through all the attacks we found because this is a turbo talk and I don't want to spend too much time on this. But see the full paper on my website. There's a lot of interesting stuff there, additional details like PBKDF, because password managers use client-side encryption, you want to do password-based key derivation for doing that encryption. But MD5 of even and odd characters is not a good key derivation function. And some password managers are doing that, so that's not great. But I want to be very clear. I still love password managers. I still recommend password managers. The point of this talk is not stop using password managers. We should get better at securing password managers. As we ask the world to switch to password managers, we should make sure that they're secure. But I still do think that password managers are a great solution to the authentication problem we have today. So, 4 different class of vulnerabilities, and I'll give one example of each. Feel free to stop me if something's not making sense, because I tend to zoom off on my own speed, so it's completely fine to slow it down. So first one is bookmarklet vulnerabilities. A bookmarklet is just a piece of JavaScript code that you install on your bookmarklet bar. So over here, these are all bookmarklets you have installed. And password managers allow you to install them as a bookmarklet. This is particularly useful on like Safari on iOS and Chrome on Android, because you don't really have extensions on those platforms. And so the problem with bookmarklets is that these bookmarklets, when you click on them, are going to run in the context of the website that you click the bookmarklet at. They don't have their own context of the password manager. So when you try to log into an attacker's website, that code is running, that bookmarklet code is now running in the attacker's context, in the attacker's frame. This makes it really hard to secure this code. As an example, let's look at the LastPass bookmarklet. This is the whole LastPass bookmarklet protocol. It's super complicated. I hate doing this, but the high-level point is first you click, and there's some initialization, stuff gets downloaded. This then downloads the password DB and decryption happens in an iframe. And then LastPass sends the password back to the page, hey, autofill this password for this particular site. Does that make sense at a high level that that's how like any bookmarklet would work? And so diving in, the first part over here, let's look at that. So Alice, the user, clicks on the bookmarklet and the bookmarklet starts running in the page. So if Alice is trying to log in on Dropbox.com, the code is running in Dropbox.com domain. And the bookmarklet code makes a request to the LastPass server, initializing all things and downloading credential databases and iframes and stuff. Over here, the first thing we noticed was Dropbox.com is a parameter, which leads me to wonder, why is that a parameter? There should be other checks beyond this parameter. And that's all we needed to do the attack. You don't even need to go into the remaining protocol to figure out what's wrong here. The attack is simple. If you're evil.com instead of Dropbox.com, you can completely mess up the parameters. You can say, you can just run the protocol like this and say, let's intercept the parameters, whatever was supposed to be sent, and change the parameter that, hey, I am actually Dropbox.com. So evil.com, the site, when you click on the bookmarklet, sends to LastPass.com, hey, I'm Dropbox.com, user just click the bookmarklet, please send me the Dropbox.com password. And this just works, beautiful. Users get whatever site's password you want. And you can keep repeating this. Once the user clicks the bookmarklet on your website, you can go through all the different sites and download passwords one after another. Which is not great. It's fixed now, but when you look at such bookmarklets, the first thing that is an antipattern here is that this Alice clicking on a link has a secret, right? Like any bookmarklet you run runs in untrusted context. So the fact that there is a secret here, there is this LastPass and edge here, is just a clear red flag. Anytime you see a bookmarklet, this should not happen because it's going to run in untrusted context. So that secret will go to the attacker's website. In addition, this becomes a trivial integrity attack. Every time you click the bookmarklet on any site, you can track someone based on this parameter. Pretty much like every bookmarklet we studied was insecure and it was possible to steal passwords of any website. So bookmarklets are just really, really hard, so don't use them. If you're using a password manager, use extensions, use apps, they are far more likely to be secure. Everyone get the attack? Alright. Part 2, classic web vulnerabilities, stuff like XSS, CSRF. All these password managers are web-based or browser-based. They're running in the web on browsers, and so they still have to worry about stuff like XSS, CSRF. And so we noticed CSRF vulnerabilities in LastPass, RoboForm, and Need My Password, and XSS vulnerability in Need My Password. I'm going to give a short example of the LastPass CSRF we found because I think it's particularly interesting. The CSRF we found was in the LastPass OTP, or a one-time password mechanism. Anyone use LastPass OTP? Okay, I had used it. So. So LastPass OTP features allows you to authenticate to the master account. To log into LastPass, if you are in an untrusted computer with just a separate one-time password and not your master password. I'm not sure what's the value of it, but it's there. And it's only valid for one use. You use it once, it's gone. You can't use it again. That's how you can use it possibly on an untrusted computer. There was just a basic, simple CSI vulnerability. An attacker on attacker.com could just send a post request to lastpass.com saying, I want to create a new password. And LastPass was like, sure. Thank you. This password will now work. And so attacker could now log in to the LastPass account of an arbitrary user using the new password the attacker gave. It's all this is not at all complicated. And so now you're able to log in. Once I know your email ID and you visit my site, I'm able to log into your LastPass account by just creating a new password. The reason I'm talking about this is that it's actually interesting because the client-side encryption saved LastPass here. LastPass does client-side encryption with your master password, and the attacker doesn't know the master password. So you can't actually decrypt the passwords. What you do get though is LastPass doesn't encrypt the usernames, the URLs where you have an account. All this stuff is in the clear. The actual password is encrypted, but all your user IDs, the websites you have accounts on, all that stuff is in the clear. So you do get all that when you execute this attack. So this is a very serious privacy breach. And interestingly, if LastPass had encrypted all that stuff with client-side encryption, they would have been safe. And so it's kind of interesting that the LastPass the client-side encryption did mitigate many of these attacks. It's still really bad because now I can do offline guessing on the encrypted password database. And so, if you have not create a password, and most people won't, you can sit around and just crunch through all possibilities on 200 machines for a day and crack the password database. Sorry, go ahead.
Is there a CD from the previous one? And
probably is. LastPass might have issued it. I don't remember. Probably is.
Do you remember when was it fixed?
Oh, last year. Early last year. Yeah.
Thanks.
I mean, in LastPass's defense, they actually log how many times these OTP requests are made, so they were able to track that this wasn't actually being exploited. The third class of vulnerabilities we looked at, and these are my favorite, is authorization vulnerabilities. And now, the first time I mentioned this, someone was like, authorization in password managers, that doesn't even make sense. It's like a single user. Why do you have authorization flaws in password managers? Well, password managers support this great feature called sharing passwords. So, you and my friend and I have password accounts on LastPass or some other password manager. We can share passwords amongst each other. And this is great, right? So Alice could say, I want to share my passwords with Bob, and password managers forwards the credential to Bob, so the next time Bob logs in, they can use the credential. This is actually a reasonable thing to do when you have couples share their password with each other, significant other and stuff like that. And inside companies, you could, Twitter account for the official social media account could be, the Twitter password could be shared. So this is actually a reasonable feature to have. But we found logic errors in the password managers we studied. Both my own login and password box mistook authentication for authorization. What I mean by this is that they didn't actually check whether you have the privileges to do something. They just check you have the account. And so concretely, here's an example on password box. The way sharing in password box works is Alice shares a password with Bob by sending a share command, right? Like, hey, I want to share this asset ID with Bob. Turns out, the attack that we could carry out was Eve creates an account and says, I want to share this asset ID with Mallory. Password box was not actually checking that Eve is the owner of this asset ID. It just checked Eve has an account. That's the authentication versus authorization problem. And so, if I know of an asset ID that belongs to Alice, I can just share it with Mallory. And obviously, Eve and Mallory can be both my accounts, and now I have Alice's asset ID. Initially, I thought this is not that bad. It got worse. Asset ID is just a simple counter shared across all password box users. And so I could just iterate to, we knew how many passwords are stored in password box because we knew the maximum number. And so we could just go through all passwords. Okay, yeah. But again, password box was encrypting the passwords. Not everything else, but was encrypting the passwords. So password encryption actually prevented password leakage, but we can get usernames, app URLs, creation date, all that other metadata, which is still pretty bad. And password, we can now start brute forcing the passwords offline because there's no it's not on the server side. So offline guessing is actually much more easier now. And the other app we studied was actually far more vulnerable, and we were able to steal arbitrary passwords. They were not encrypted. Make sense? Or can I move on to the next one? All right.
How long did it take you to test that? Like a day or like 18 years?
I don't remember. This was a while ago starting. Yeah. And also this is joint work with like folks at Berkeley, so 4 people, like 2-3 people. Yeah. But I would say guessing the vulnerability is easy. Converting it to an exploit was when we noticed the asset ID. So okay. Alright, the last one is also pretty interesting, user interface vulnerabilities. So, one of the great things about password managers is that they can protect against phishing. Phishing is one of those like really hard problems, I think, because we don't have a solution for it. And I think one of the only solutions we have today is password managers, because your password manager will know what website you're visiting and will refuse to autofill the password if it's the wrong website. So a phishing website can't really easily trick you into getting the password. But this is like completely lost if the password manager itself trains you into phishable behavior. And when we looked at how password managers work, we saw that both LastPass and RoboForm encourage behavior that is really vulnerable to phishing. And I'll give you an example of this for RoboForm. So the way RoboForm works when you use its bookmarklet is you click on the RoboForm bookmarklet and it will open up a login window right in that page using an iframe. For an attacker, this is great. You can just block the iframe from being created and then create your own iframe saying, hey, log into your RoboForm with your password and give me your password. This really sucks. And to like really give really underline how easy this is to do, I'm going to switch to a video if I can get my Mac to do it. So this is RoboForm, and I log into RoboForm, create a user ID, password, whatever. And I go and install the bookmarklet as RoboForm asks me to do. And let's say I'm trying to log into this email. This is the. Whoa, sorry, it crashed. So sweet. But basically, this is like really easy to spoof, and you're training users to type their passwords into an untrusted area, which is really not that great behavior to encourage. What we really need to do is train users, hey, if you're not logged in, open a new tab and type in your password. Go to roboform.com and type in your password manually. Don't trust a link that says this is, or don't trust an email that says this is RoboForm. Insist on opening a new tab manually.
Spoofed its own custom UI by making it look like a web.
Yeah, so that was the other thing. Yeah, so RoboForm was spoofing Windows, we spoofed RoboForms, like so many. But like, this doesn't work on a Mac or Windows 7, this is like Windows XP. I was very confused by that. Alright, so what are the mitigations for all these attacks? I discussed a bunch of attacks, and there's no magic bullets here. There's no like one answer that will solve this. This is just, we need an SDM, we need a proper systematic approach to developing password managers. So for example, for bookmarklet vulnerabilities, this should be just really simple. It should just load an iframe and do all the work inside an iframe, because the iframe is really the only safe boundary in a browser. And then when you want to send back the password, post message it with the correct target origin. So like if you decrypted a password for Dropbox.com, post message it with target origin of Dropbox.com. So bookmarklets we studied, we are post messaging it with target origin of star. So it's really easy to steal the password. That is not great. So these simple fixes can then, even if you screw up something else in the middle, these mitigations can save you the password. This change? Yeah. Bookmarklet changes are done. Actually, the only change they didn't agree to is the UI, because the impact on usability was too high to fail. Our recommendation was just ask them to open a new window manually, and this is like, no, this is too much of a usability. Which is fine. I mean, I do want more people to use password managers, so it's fine. For web vulnerabilities, none of the password managers we studied had a strong CSP policy. But considering the sort of data they are handling, I would really love for them to have a very, very strong CSP policy. Maybe have simple header-based CSRF protection everywhere. Don't worry about whether or not this needs to be protected. Just protect everything. The Web AppSec working group is working on stuff like entry point regulation. Once that's released, I would love for them to adopt these mitigations. All these modern techniques, if there's one class of web application that should adopt them, that can argue that the security is important, it's password managers. And so it's kind of crazy that like Dropbox has a better CSP policy than password managers. So hopefully they will start adopting them soon. And in the UI vulnerability case, as I mentioned earlier, we really need to train users manually open a tab. Don't trust, especially for password managers, because if you get phished for your password manager, game over, right? Like all your passwords are wrong. So don't trust, always log in manually in a new window. The authorization vulnerabilities, these are hard. There is no simple mitigation for this, but like simple other mitigations that don't have counters as your identifiers, have goods or really big random numbers as your identifiers. Or simplify the sharing model, maybe that will help you reason about it. And so before I wrap up, I just want to say this is wide spectrum of vulnerabilities that we discovered, and there's no magic bullet here. Security is just hard. But one of the cool things we found is that in many cases the client-side encryption actually helped and mitigated many of these issues. Did save and did prevent easy exploitation. So that's kind of cool. I didn't expect it, so that was great to see. And we just like when you're developing these passwords, any web application really, systematic defense in depth is really the only way to go, I think. With that, I'm going to wrap up. Thank you. Bye. Thanks. So this was intentionally really turbo because I knew I was before lunch, and this sort of stuff gets people really excited. Password managers, and for some reason, passwords get people really excited. So I'm happy to take more questions, but if people want, I can talk about more attacks also. But anyways, more questions. Yeah.
Did you analyze the plugins for various browsers as well, or did you focus on bookmarkets and web applications?
No, we only focused on the extensions inside. So many of the, other than the bookmarklet attacks, all of them work even in the extension case. So the CSRF, XSS, all that, we studied the plugins. Yeah. Yeah. That is not something I'd admit. So, but I use a password manager. I use yeah. I mean, it's not like I have some knowledge of. I use 1Password and LastPass. Both actually, just because I'm weird and I want to keep seeing what's the evolution. I think LastPass is great in terms of usability. It works really great on Android. 1Password, it syncs with Dropbox, so the password database is not in the cloud. It's with, I mean, it is in the cloud, but it's in Dropbox, so it has two-factor auth and stuff. So it's a trade-off. I think they're still figuring it out. And I'd be curious what people use for. Who uses LastPass? Okay. Who uses 1Password? And KeyPass? What else is left? I'm not trying. Chrome Password Manager, yeah. Whippers, yeah, okay. Yeah, so the one Chrome developer here uses the Chrome Password Manager. Two, the Chrome Security Manager uses the Chrome Password Manager. And yeah, Dan here uses the Firefox. So yeah, I think I'm holding you back from lunch, so thanks a lot for attending, and I'm around both days to chat, so feel free to say hi. Thanks a lot.